about the universe and our solar system. The universe is a topic which fascinates all of us. On any dark night, when we look up, even with unaided eyes, we see thousands of stars, and they are just decorating the complete dome over us. That pitch dark sky becomes beautiful because of these stars. You know, some of you must have read this, that with unaided eyes, without any telescope, binoculars or anything, we can see up to 6,000 stars. But yes, not all will be seen at once, because you know, half the sky is in the dark, where half is in daylight. So you can see, say, 3,000 stars. That too, it's maximum. Mostly you will find, these days you don't find such dark places. So you barely see a few hundred stars when you go out on sky watching parties. But is that all about the sky? No. Sky, or the universe. We often use the term universe, or sometimes even cosmos. That way, cosmos is universe itself, but in a most orderly form. That means it's a complete sketch of visible universe, but in a most orderly fashion. You will find, like, perhaps some of you could be aware that an optical telescope launched by NASA some 20 years back, or more than 20 years back, by name Hubble, has taken wonderful photographs of space or the universe beyond your own galaxy. You know, you are in the galaxy by name Milky Way, and there are such billions, hundreds of billions of such galaxies. Galaxy is nothing but a habitat of stars. So many stars, they reside together forming one galaxy, and there are such hundreds of billions of galaxies. You can't even count them. The photograph taken by Hubble shows small fudgies, kind of small spots, smudge kind of areas, or sharp pieces. They are all galaxies. So sometimes we wonder that how big is this universe. We can't even measure it. Let's look at a simple our own galaxy so as to know its vastness. Like I told you, likewise there are hundreds of billions of galaxies. 1 billion is 100 crores. So 100 crore into hundreds of such, billions, will give you 100,000 crore or more than that number of galaxies. So they are scattered in an orderly fashion. That makes the cosmos. So coming back to Milky Way, this is a typical spiral shaped galaxy. It has this galactic center or center of your galaxy, and from where so many arms are emanating, they are coming out. Like they are spirals, coming out spirals. These spirals are named differently just to recognize them. Now there are estimated 100 to 400 billion stars. That means if I sum it up, so many crore stars minimum, or up to these many crore stars. So you cannot really imagine the size. Now you know, the fastest thing that travels is light. All of us are aware of that. Speed of light, most of you must be aware that it is 3 lakh kilometers in 1 second. So within 1 second, light will travel from one place to 3 lakh kilometers further. The light from sun reaches to the earth in about 8 minutes or 8.20 minutes. That means light also takes this much to reach to your earth. And you understand what is light minute then? The distance that light travels in 1 minute is 1 light minute. Like there could be 1 light hour or 1 light year finally. So light year is the distance that light takes to travel in 1 year. So that's a huge distance. You can understand that 1 second is 3 lakh kilometers, and likewise 1 light year would be something which is beyond our imagination. But remember, all these sizes become small when we talk of the overall grasp of this complete universe. Take an example back to our galaxy. Light from one end of galaxy reaches to the other end of galaxy in about 1 lakh to 2 lakh years. I am talking of years. Just light takes this long to reach from one end of galaxy to the other end of galaxy. That huge is the galaxy. With so many stars, 100 to 400 billion stars in this. And of all these stars, a very ordinary star is our own Sun. It is placed on one arm that is typically called as Orion arm, or sometimes Orion Cygnus arm. One very small arm. And this is about 27,000 light years away from galactic center. 27,000 light years away. So here is the Sun, and around that we all, forming solar system. So you can imagine how tiny it could be. Just a very tiny object. Take an example, if I consider Sun of sand size, just even smaller than a particle of a sand, and if I place it on top of my palm in the center, that complete solar system will be of my palm size. And this is in this galaxy. If I consider palm as a size of solar system, then size of this would be 2 times of that of India. So you can imagine how small the Sun is. In the huge canvas of double the size of India or even more, we have this much of solar system in which a small sand particle is Sun. And can we imagine size of Earth? Just cannot. Because it's just negligible. You can't even find it out. So such billions of solar systems are scattered over space, forming a complete universe. Now back to our own existence in the solar system, because that is the topic of today's discussion. I know you are clear that the size is very huge, light travels, and how about the nearest star to us? Even the light would take 4.5 years to reach the nearest star from Sun. So that is Alpha Centaurus. So that star is, even if we say it's the nearest, light may take more than about 4.5 years. So reaching to that star is impossible. In the present technological advancements, we cannot think of going to any other star. We cannot even think of going to nearby planets, let alone the stars. So, coming back to our solar system, we know Sun is occupying almost 98 to 99% of total mass of our solar system. All others, what do I mean by all others? There are 8 planets. Now there are 8 planets. Earlier we were taught like there are 9 planets. Pluto is the 9th planet, which is now considered as a dwarf planet. It is not a regular planet. It is a small planet. So 8 planets. Many of them have their own satellites. Like Earth has our own moon. Then Mars has its own 2. Then this giant Jupiter has more than 60 number of small moons. So many are here with Saturn as well, and half of them with Uranus and Neptune. So all of them, plus this in between Mars and Jupiter. This is Mars and this is Jupiter. This is your Earth. Mars and Jupiter. There is a belt of small stones, measuring sometimes up to few kilometers. They are orbiting. All of us are orbiting the sun. So they are orbiting. This is called as a belt, which is asteroid belt. So this has such stones orbiting, and then we have the giants. These are gaseous giants in the solar system. They are not as dense as these inner planets. Inner planets, you know, Mercury, Venus, Earth, Mars. They are rocky planets with more metals inside them. Here they are with more gases. They are giants, but gaseous giants. Now, these all have their own period of rotating around its axis. Their days are different. Then they orbit around the sun. The orbital period is different. Like we know, we orbit the sun in about 365 days. They orbit fast, like in 288 days and so on. They orbit slower, as they have to complete large orbits around the sun. Then some of them keep orbiting around their axis quite fast, and some of them very slow, like this goes very slow around its own axis. So depending on, like if you go to the nearest one, which is of half the size almost of the Earth, that is of Mars, it has a day of about same size or same duration of that of Earth, but quite slow while orbiting the sun. This is of the same size. Venus is of almost same size of that of Earth, but is very hot if compared to Earth's temperature. Earth's temperature maximum it could go up to 37 degrees. Here it goes into hundreds of degrees Celsius. As against this, then they become very, very cold, because they are going away from the sun. As I told you, light reaches here in 8.2 minutes. Naturally, it must be reaching quite fast here. In little over 3 minutes, light reaches here. Little over 6 minutes, light reaches here. 8 minutes, and then maybe 12.2 minutes it takes for light to reach up to Mars. And then light reaches, it takes sometimes even more than 1 hour, 2 hours and so on, going up to the last one. It takes about more than 3 hours to reach to the end. Beyond this, again we have these belt of some kind of snowstones orbiting, that is Kuiper belt. From here sometimes these comets, they suddenly come into the solar system and they start orbiting the sun. Many such comets, they even visit atmosphere of the Earth. They become visible. Even Neowise is a planet, this comet which is visible right now by even unaided eyes. So that makes a complete solar system. Now, how big is the sun if compared to the Earth? Let's imagine, it's the imagination verse. If we take a weighing scale, and on one side is the sun, and on the other side we put Earths together. These are all Earths. As a mass of sun, we will need about 3.3 lakh Earths to balance the sun. So its mass is 3.3 lakh times more than the Earth's mass. Now if I imagine, like in a grocer's shop, you find a jar filled with small toffees. If I imagine sun as one huge jar in which I am putting Earths as small toffees, how many Earths can fit into the sun's size? The figure is very big. It is about 13 lakh Earths can fit into size of the sun. Or you can go for another comparison, just to know that how big the things are. If I start putting Earths into Jupiter, Jupiter becomes a small jar. It will take about 1300 Earths to fill this Jupiter. Small marbles, if you are putting into one's big ball, it will take about 1300 Earths to fill complete size of the Jupiter, and such 1000 will fit into the Sun. So that big is the Sun. It is something which you cannot even imagine. The Sun also orbits around its own axis. It rotates around its own axis. So that rotating Sun also is not like Earth rotates around its own axis. It completes one rotation in 24 hours. We see day and night because we are rotating around our own axis. Sun also rotates around its own axis. It takes 25 to 27 days to complete one such rotation around its axis. The Sun here also orbits or revolves around this galactic center of the galaxy, which is quite a bright spot. Sometimes we assume that there is a black hole here which is pulling huge mass. Now it becomes a galactic cloud, so you cannot see anything here. It becomes a very whitish cloud. So that is the center of the galaxy. Your Sun also orbits around this center. But in how many years? It is 230 to 250 million years. That means 23 to 25 crore years. So that takes for one orbit of the Sun around galactic center. You can't even imagine that. All of this, whether Sun or solar system, the Sun particularly was born nearly 4.6 million years back. 1 billion is 100 crores. So 460 crore years back, Sun was born. It was a dust and it came together forming a star, and some part of it became these planets or planetary system. In this first 4.6 billion years to 4.5 billion years, these planets were formed and they started orbiting. That formed our solar system. So this is just to make you aware that Sun, solar system, they are very nearby. They are just as good as they are sitting around us. Like I showed you an example of standing on your palm, orbiting on your palm around the Sun. But in reality, if you look, overall universe is such a huge thing. It is impossible to encompass its size. So those who are interested in the astronomy or cosmology, they can choose this, or space science, they can choose these streams once you complete your graduation or once you complete your 12th standard at least. Then you can take up any of such topics to study further, because these topics are something which are not easy to just encompass or just to fathom. You have to really study them. Let us make a small solar system, a very simple solar system showing Sun. Sun also is not just a shiny thing, it has a lot of granular structures on that. So you will find that the Sun given in the kit also has the small granular structure, and these 8 planets, inner planets and outer planets, will make a solar system, and once you do it, you can hang it on top of your study table. So always you will remember there is one subject I have to study sometime in my life, that is universe or cosmos or overall astronomy. So let us get going. We will make solar system now. So let us begin the activity of making of a solar system. For this, the kit has one complete printed sheet from both the sides. So first thing what you should do is to take out these pre-punched shapes. You must remove them very carefully. There could be a sellotape also somewhere. Just take it out. This is of course quite well-known planet with rings. That is your Saturn. a gaseous giant. It is large enough to accommodate about 670 number of Earths in its as a part of its volume. Then this is Jupiter. You have to take this out carefully again. Take out all one by one. There may be serotape somewhere. You have to look for if there is serotape. You have to be more careful. Let it take some extra minute or two, but never go careless while doing such small activities. And the names are very well printed on surfaces of these planets, so they won't be, you won't go wrong while locating them. So this is your Mercury, this is Mars, and the source of our energy, that is star Sun. So this is your Sun. You know, Sun, this is a photograph of Sun taken by one mission by NASA. That mission is named as Voyager. They are all original photographs. So you can see Sun has such kind of granular structure with all some activities happening on surface and such flares jumping off its surface. This is a lovely planet Earth. We are taking that out now. Uranus. This also has rings, but they are not visible to us. Venus, that is the brightest object in the sky, in the night sky after the moon. Moon is of course the brightest, but then is the Venus. Now I have removed everything from this punched paper, so I don't need it now, so I'll just move it away. Even these small pieces, I don't need them. Now we have these planets. The four of them, they are inner planets and they are outer planets. The kit has this kind of hub structure. There are two such hubs. Then there are these steel rods, one side with some plastic caps, other side have those bent structures. So four of them are small, four are big. I'm just separating them. Big ones are kept on one side, the small ones. And a bundle of thread. The first exercise would be cut 6 small pieces of about this length. You can say it is little over 30 centimeters I am taking. So using scissors, I am cutting this. This is approximate, so you can plus minus a little bit, it doesn't matter much. I am using same to go for the second one. So the second one. Then I join this to get third one. Likewise, we may go for 6 identical pieces, small pieces. So let it take, it may take a minute or two. I think I have completed 5. Nothing wrong. If we have one extra, doesn't matter really. Yeah, we need one more. So 6 are taken. Now we need 4 more thread pieces, but they should be of double the size of this. So I'll go for 1 and double of it. So 2. So double of it approximately. So I'm keeping this away now. These 6 pieces are cut. I'm cutting double size piece. again joining this to go for one more piece. It may be little less than double, you don't need exact double of it, but it's okay. Then third one like this. And the last fourth one. So the thread part is done. This is the fourth part. Fine. So threads are ready. Now the task is quite simple. I am using first small threads. I'll take one. See, we have to pass one end of this thread through a J-shaped cut already taken into this pre-punched shapes. So what I am doing is passing this thread through this J shape. Then the same thread I am taking into the small part of this J. So this J, the thread has reached to the end of it. So it can easily be hanged like this. Very easy. So I have used one small thread here. Then these 4 small threads out of now what are remaining, 5 are remaining. So I am taking 4, and same way I am locating for these J shapes, inserting them. So J, it goes in, and then we have to turn it to the end of J, so you can easily hang it. So Earth is done. Say this Uranus is a big outer planet, so I am separating it. Next one I am taking is, say what I have done is Earth. The next one I'll take is Venus. So we know Venus and Earth, they are of identical sizes. The way we did this for the Earth, same way we'll do for other small planets. Mars, Mercury, and of course Venus. Now coming to next step. This is a hub, and we have to insert these spokes from all 4 sides. 1, 2, 3 and 4. So this is a simple step. We'll choose these 2, Earth and Venus, because they are of almost same shapes. We'll just attach one thread of Earth to one side by tying a knot here. So in this activity you will find you have to really make knots at so many places. So Earth is attached. Opposite to Earth we'll place this Venus. Venus is just a little smaller than Earth. So Venus on one side is done. Then we'll go for Mercury on third side of this structure, and opposite will come Mars. So Mars, which is reddish in color, we know, will come on this fourth side, opposite to Mercury. In the middle portion of this entire solar system should be the Sun. So obviously that we have to then look for. So these 4 sides are done. And we'll just go for this last Sun. This has to be inserted, this thread has to be inserted into the hole, and you have to tie a knot. So the first part of this solar system, the first half is done. Now you know the same process we have to follow for next planets, 4 planets. I'll just begin with this way. First we'll add these long spokes into 4 sides. So the structure gets ready. 2, 3 and 4. Quickly we'll insert the threads. Now we have to go for long threads. Into the J attachment of the punched part of all shapes, like this planet, that is most spectacular planet we know. So in Saturn we have done it. That is a ringed planet. Opposite to this will come Jupiter. Same J structure, and we are inserting this. And then 2 identical looking planets. Uranus. Both are blue, but Neptune is a dark blue planet. So you know that there is a shade Neptune blue. So that is this also, but it is a little greenish. Uranus is a little greenish blue, but perfect blue you will find is this. Now we have to tie them again to 4 sides of bigger structure. The threads are also big. So I'll start with Uranus. Tie it to one of the 4 ends. So this one is here, I am doing it. So Uranus is tied on one side. Opposite to this Uranus will be Neptune. So they are almost identical, so they can balance each other very well. And of course the last 2 places will be for 2 giants. One is Mercury, one is Jupiter, another one is Saturn. So now this Neptune and Uranus are on 2 sides. Earlier I did Neptune and now I am doing Uranus actually. So Neptune, Uranus done, and on one side now Jupiter. Here is Jupiter, and the last one is Saturn. So 2 assemblies independently are getting ready. We have to then of course join them. But before I join them, this is the last one I have to do. And once it is completely done, I will just stand up and show you that how this solar system looks like. Okay, now we have to join like this. This upper and this lower should be joined. So I am taking the last small thread which is still left with us. Pass through this, tie it here. So you know that sun is attached to this small assembly in the bottom. So this upper end of this hub is used, and I am passing this other end of this thread through lower hole from the upper hub. So to pass this through this hole. The holes are big enough so you can easily pass. I think I should do it once again. It is all complete now. Just wait to one final step will take. See, now finally we need to hang this to some support. So we may insert thread through the upper hole and tie a knot. Now I just show you first by lifting it here itself, and then I'll stand up. See, basically this is how it's going to come up. So all planets will come in almost one parallel line. Let us cut this unwanted part of this thread. So it can go to some place. And small and big planets, if done properly, they'll come just in one line. This is So I'll stand up and show you this complete ray. You can easily look at it every day, and your interest in astronomy, space, cosmology and so many topics related to this will definitely get a new boost